to, let's just ensure it's working. Yeah, it's outputting the message welcome. Now, this is what I want us to do. My first program is going to be how to use if statements to make decisions. The use of if statements to make decisions. As I've indicated from our coursework, from classwork, human beings normally make decisions when there is a condition they are testing, so they decide what action to take place or to what action to perform. In our case, let's do a very simple case where we want to check something. So case number one, let me have a simple program. C program to check if you passed a unit. Let's do that. So in my main program, remember we are writing our code inside the main function. I will declare a variable that will be holding score, int score. I have a variable called score. And whatever value I give score, the program will tell me whether I've passed or not passed. So int score, now let me capture the score from the keyboard using the scanf function. I'll use the scanf function to capture the input from the keyboard. So whatever I'm going to get the keyboard, let me first tell the user to enter something using printf. So the user is being asked, enter a number. Enter a number. That message will appear on the screen asking the user to type something, a number. Okay. Then I capture the number from the keyboard. Whatever I want to capture is an integer, so %d. And whatever I'm capturing will be score. Now, when you're using scanf, you start with ampersand and the name of the variable. This is formatting. This is, you are telling the compiler that the number to be captured from the keyboard will be an integer or a digit, and the integer will be stored in the variable score. That's how you do it in scanf. And of course, we have already declared the variable up here as score. So once you have captured this, now you can use it. Now you can use it in your program. So with the value of score known, now I want to test whether what was input by the user allows the user to pass or fail. Okay. So assume scores of 50 or higher equal to pass. Okay. Assume 50 or higher is pass. Okay. That's a comment. So let's now do that statement and say if score is greater than or equal to 50. If score is greater than or equal to 50, then inside here I would print a message and say pass, like that. So let's go through the code. You understand what this does by now. You understand the main function. I've declared a variable called score. On this line, I'm asking a user to enter a number. I'm capturing the number from the keyboard and storing it in our variable score. The number is a digit, it's an integer. And I'm now putting an if condition. This is decision making. I'm saying if the number stored in score, the variable is score, if the value in score is greater than or equal to 50, print the message pass. So let us run this. Enter a number. I'll try a number like 89. My program says pass. Let me run it again. Enter a number. Let me try a number like 24. Nothing happens. You understand what I was explaining in class when I said when you're using one if statement, you will only test one condition and you will only perform one action when that condition is true. So for your program, this one, because it has only one if statement, if this condition inside bracket is true, then you will run this code. If this condition is false, nothing happens. That's why you can see the program is not doing anything. So let's try. If I have 87, pass. Let me run it. If I have 56, pass. If I have 77, pass. If I have 40, nothing. Why? The program does not know what to do for scores less than 50. Because here we have told the program that when the score is 50 or more, then it should display pass. What if the score is not greater than or equal to 50? We have not told the computer what to do. Is this part of the program understood? This is the first type of if. Simple if, with one condition, one action. Understood? I need confirmation. Those of you without mics, you can type the message, okay, 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 okay. For those who have understood, just type the message, okay, okay, okay. Confirm you're understanding that concept before I move to the next one. Some of you are doing thumbs up, which is fine, thank you. All right, so now I want to implement the next part of if. Some people are trying to join still. All right. I hope the streaming is working so you are able to see still, even though you are not able to join. So let's go to the second implementation of if. Now I want my program to not only display pass when my score is 50 or more, but to also tell me fail in case my score is not greater than or equal to 50. So I want to introduce the alternative. If I don't pass, I fail. So in that case, I will introduce after this, I will introduce the else part. And in the else part, I simply print the message fail, like that. You see, I've only said if the score is greater than equal to 50 is true. If this statement is true, display pass. Otherwise, meaning if this condition is false, jump here and go to the next part after this if. The next part is saying else, and inside else we are saying display the message fail. Now this program should be able to handle marks that are 50 and above, as well as marks that are below 50. Let's try that. Enter. I try 78. Pass. Enter. I try 32. Fail. Enter. Let's run again. 90. Pass. Try something else. 3. Fail. So your program can now decide whether you passed or you failed, depending on the marks you entered from the keyboard. I can share the code with you through the text, so the chat section. Let me do that. You want to try it out? There we go. Any question? Any question regarding the implementation of if else? I've already added this part to make sure that when this condition is false, we jump everything until the end of this if, and that means we start here, and this one is only saying fail. You agree with me, if you did not score more than 50 or more, you scored less than 50. So there's no point testing. If you know that you either scored 50 or more, then you did not score below 50. If you did not score above 50 or 50 or more, you must have scored less than 50. That's why you simply say else, interpreted to mean otherwise. If this is not true, it is this one. Understood? I need confirmation. Confirmation that you have understood so that I can go to the next if, because I want to do a grading system before you so that you can appreciate the whole concept. Someone has raised their hand. I don't know. Oroba Otieno, your hand is up. What is it? Oroba, your hand is up. All right. All right. Maybe you clicked it by mistake. That's fine. I've received enough confirmation that you people understand what it is that we are doing. Now, let's make the program more comprehensive so that it can take care of different grades. So we can call it now university grading system. All right. Basic grading system. Enter. Let me call it enter your score. Enter your score. And I can even advise the user the score is 1 to 99. I'm advising the user what to enter. Enter your score 1 to 99, a value from 1 to 99. That message will appear. On scanf, we will capture the score. All right. Then now we will try the different applications. We will say, for example, if score is greater than or equal to 50, let's start from the grade A. If score is greater than or equal to 70, Okay. And or is less than or equal to 99. So I need brackets to make sure I separate these things. This one also should be in brackets so that we have two brackets. So the overall bracket for the if statement, there's this one to take care of the first expression, score greater than or equal to 70. There is an and here, meaning we want this statement to be true and this other statement to be true for the entire if to be true. And when everything is true, we can execute the code inside here. So score greater than or equal to 70, okay? Score greater than or equal to 70 and score less than or equal to 99 means A, grade A, okay? Now let me try having many of those. So I'll have another one down here, which will be else if score is greater than or equal to 60. I'll show you another version later on how to do this. So if score is greater than or equal to 60 and less than or equal to 69, then we call it grade B. Okay. So I'll just copy and paste so that I don't have to keep typing what we already have. So here I'm saying if the score is greater than or equal to 50 and less than or equal to 59, then the grade is C. Okay. Else if, let's try again, score greater than 40 and less than 49, then that one will be equal, less than or equal to 49, of course, that will be a grade D. The last one, or the second last one, if score is greater than or equal to 1 and less than or equal to 39, then that becomes an E. Else, you failed. Do I say failed? I would say invalid score. Invalid score. Or I can say invalid input. Let's run it, then I'll explain what's happening. Enter score, and it's between 1 and 99. So let me try 90. My program says A. A. Let's run it again. We try 82 or 81. Okay, A. Let's run it. We try 75. A. Okay, let us run it with 66. B. Let us run it with 60. B. Let us run it with 55. Okay, C. Let us run it with 50. C. Okay, let us run it with 49. B. Let us run it with 44. D. Let us run it with 40. Still D. Let us run it with 33. E. Let us run it with 23. E. Let us run it with 12. E. Let us run it with 1. 1. E. Now let us try other cases like 0. Invalid score. You can see that. Invalid score. Let us run it with a number like 500 max. Invalid score. Let us run it with whatever it is. 50, whatever, a number like that. Invalid. Let us try 100 itself. Invalid. So this program is able to effectively tell you what grade you have depending on the scores you have, whatever value inputs. Of course, you start facing challenges if you try to enter, and you see now we are dealing with numbers here. But a user can try to enter something like X. So you see X is also being classified as invalid score. Some people will try to enter something like I have 78. That's not a number. Yeah, 78 is not a number, it will be problematic. But because we have said we are scanning for a number, so when you enter something like, let's say you try 67X, it will look for the 67 only and ignore the X. So let's try 67X or 70X. You see, it's telling you AY. It was able to pick the number and ignore anything that was not a number. That is the purpose of formatting it %D. Look for the number. Let's try that. If I said enter your marks, let's run this. Looks like the server is misbehaving. Let's say I have 70 marks. You see, I'm supposed to enter. Look at the code. Enter a number 1 to 99, but our users decided to type 70 marks. 70 is the number. This is not a number. So what will the program do? It says grade A. It considers 70 and ignores the rest. You understand that? Are we okay with that so far? Feedback, I need feedback. I'm sharing this code with you so that you can try it out on your own. It's going up to else. The else part is not very clear. So let me share that again. Based on what we have covered so far, that's not a bug. It's supposed to work like that. That's why we format our input. When we were doing the input, that's why we accepted the input to be percentage. It is simply look for a number. You know, everything else, look for a number. Of course, there are ways you can always prevent users from typing other things. But for now, it's okay. It's not a bug. If you type A70 instead of 70A, we can try it out. There's no problem. Let us run it. A70. Invalid. Because it's trying to check, it realizes it's beginning with a letter and it's not finding a number there. But if you start with the number 70A, it will pick the number and ignore anything that's not a number. Like that. Nyambura, I think you're answered. All right. A70 will give you different results from 70A. The scanf percentage, it is scanning for a number, and where it finds a number, it ignores anything that's not a number. But if you start with something that's not a number, then the whole thing is discarded as treated as a bad thing. What is a couple of numbers 70, 69, 50 at one go? What do you mean? Makaria Sirungu asking, what is a couple of numbers, e.g. 70, 69, 50 at one go? What is that? Oh, you enter all of them at once. Unless you're dealing with an array, that will be problematic. Let's see. 78 marks, 90 marks, and 8 marks. What happens? A, let's try to mix them. 45, 90, 65. B, because the first one is what it will consider. After the space, remember space is not a number. Space is not a number. So when it meets a space, it knows you have finished your input. It will ignore the rest. So it will consider this one and give you D. That's why when you reverse and give it 80, then 43, it will use the first number 80 to do the calculation with grade A. After space, it will know you have finished your input. I want to assume the code is understood. Can I get confirmation? Code understood? Yes, 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 yes. Someone is saying not understood. Yes, yes. Yes. Yeah, majority are saying yes. Ask those colleagues. You can see those who are typing yes, they have understood. Maybe they can explain a bit of it to you because of time constraint. I will explain the code line by line so that you can understand. Okay. Let me go through the code. I believe you understand what this statement does. You understand. So from the start, we are trying to import or copy a header file containing the functions for inputting from the keyboard and outputting to the screen. Here we are creating the main function. This must be there. On this line, we are creating a variable called score that will be storing the number that a person will be entering from the keyboard. We want to type something. So as you type that value of your score, which is numeric, it's a number, you store it in a variable called score. Now, you are asking a user to enter the score. The user is supposed to enter score. And in this message, you are telling the user, whatever you enter, try to enter it a range of 1 to 99. So this is just a message that will appear on the screen, which you are seeing here. Enter your score 1 to 99. Now you will assume the user is going to enter a score. So whatever the user will enter will be stored. But now let us enable the user to enter the actual number. Remember, this one will display the message. But after the user has typed something, we need to capture what the user types. How do we do that? We use scanf as a function. Now, because we want to extract a number from what the user enters, we format the number first in quote marks. Percentage D means expecting a whole number. Percentage F would mean you're expecting a decimal. Percentage C means you are expecting a character and things like that. So we format what we are expecting from the keyboard. Then when we get it, we store it in the variable called score, which we declared before. And the score, that's how we do it. You start with the ampersand and the name of the variable. Score here is the name of the variable we declared to hold whatever the user will be entering at the keyboard. Now that score contains something the user has typed, we use it to test whether what the user entered is an A, a B, etc. So we are now applying decision making. Our first decision point is this. We will assume it is A. So we will say whatever the user entered, which is stored in score, if it is greater than or equal to 70, and whatever is in score at the same time is less than or equal to 99, meaning it's a number from 70 to 99. If there's a number between 70 and 79 and 99, we will display the message A. Now, if what was entered is not ranging from 70 to 99, we will test it in the next condition, which is else if. Now, in the next else if, we are saying if the score is greater than 60, greater than or equal to 60, and at the same time less than or equal to 69, then we'll consider that one as grade B. Otherwise, if it is not A and it's not B, then we test it under grade C, in which case we say if the score is greater than or equal to 50, at the same time less than or equal to 59, now that must be a C. Otherwise, if it's not an A, it's not a B, it's not a C, we are going to see whether it's a D. We check whether it's greater than or equal to 40 and less than or equal to 49, in which case we decide it's a D. Otherwise, we still check if what the user entered is greater than or equal to 1, but less than or equal to 39, we consider that one an E. Else now meaning, in case it is not A, it's not B, it's not C, it's not D, it's not E, then whatever the user typed or whatever the user entered, it must be an invalid. Because remember, we are telling valid score is 1 to 99. So anything that's not 1 to 99 will be considered invalid. So when you enter 100, it is invalid. When you enter 0, it is invalid. When you enter a negative number, it is 0. When you enter a letter, it is 0. When that is done, you return 0, marking the successful code execution. Then you close the main function here. Is it better now? All right. Of course, there's a way of writing that differently than saying as if in all those cases. There are other ways, but for now, we are going to use it the way it is. Somebody saying, what is the difference between double vertical bars and the single vertical bar? The double vertical bar means or, this or that. Maybe we might see an example where you might need to use it. So that is to answer kinyu or kinoti. The double bar is the equivalent of or, just like the double ampersand is the equivalent of and. Stop it there. So let us go to looping the next 30 minutes. Let's do loops, okay? Looping. Let's go to loops, okay. In the loops, our business is to repeat a task several times. So let me go back to this original code and remove everything else except the main function, like that. All right. So here we are dealing with looping. Let's looping. Looping is what we are calling iteration, is what we are calling repetition. When you want to perform a task multiple times, you do that. So our first case is to use a while loop. And for every loop, you need three parts: initialization, condition testing, and continuation. So let's do a while loop. While loop. So with the while loop, you do initialization first. Initialization is int 0. I want us to display the first 10 numbers. Int 0. I'll comment this one as the initialization phase. So after initializing our variable int I, we have a variable called I. You can name it whatever you want, or you can call it count. All right, int count or counter. All right, this variable I will be used to make the counting of how many times we are repeating. So we have a variable called I assigned to 0. So that's initialization. Then we go to the while condition. Then we say while I is less than 11, for example. While I is less than 11, that means I can be 10, can be 10, can be 10, can be 9, 8, 7, etc., but cannot be 11. So that means the maximum is what? 10. I like doing it this way, less than or equal to 10. To me, it communicates better than the others. So while the value of I is less than or equal to 10, we will display the value of I itself. But I is a number, so we will format it as a number. Then we display the actual value like that. So that's what we are doing inside the while loop. So we run that. There's something, of course, I've not done the increment. So you see it's doing 0, 0, 0, 0, 0 endlessly. The loop is not ending. A mistake you need to avoid. Now, I want to tell the program to end this so that after it displays this, it increases the value of I by 1, like that. Now we can get 0 to 10, like that. 0 to 10, like that. If you want to create some spaces between the numbers, maybe you can start with a space before you display the number, this space. Okay? Now you can create those spaces. If you want the numbers to be displayed each time with a tab, you can do that. Number tab, number tab, number tab. You see the space is bigger now. That's the effect of this /t, tab. But just a single space is okay to make it display 1, 2, 3, up to 10. Now, if you want these numbers to be displayed vertically, each number on its own line, now you can start this line with /n, which is the new line character. So it will push everything to its own line. Okay? Like that. 0, 1, 2, 3, all the way to 10. That's the effect of it. Or alternatively, display the first number, then for the next numbers, you push them to the next line. You'll do that. I believe that is not difficult to understand, is it? So we initialize the number, we're starting at 0. We ensure that the value in I does not exceed 10. So the maximum will be 10, the minimum is 0, maximum is 10. We display the value itself, we increase it by 1, then we go back and test. If it is true, we display the number, we increase it, we go back. If it is still less than 10 or equal to 10, we display it, we go back, increase it, go back here, test, display, increase, test, display, increase. Keep doing that until this condition inside here is false. At what point is the condition going to be false? When I is no longer less than or equal to 10. That means when I is 11. When I is 11, that means 11 less than or equal to 10 becomes false. What happens? If it is false, we skip the code inside the opening. Find next the code that says return 0. What does return 0 mean? End the program successfully. Understood? Or there's a question? Tell me you understood or there's a question. Many are understanding, understood. There are many format specifiers in C. Let me Google for you. Format specifiers for different variables in C. They are there. You can see that for yourself. Percentage C is for a character. Percentage D is for an integer. Percentage F is for a floating point number. Percentage O is for octal. You can see, you can continue. Those are things you can Google and you'll be able to find them. Depending on the nature of task you are doing, you should be able to find that. They are here. Percentage U for unsigned integers and others. But for now, we remain with percentage D for a number, whole number, percentage F for a floating point number, including a double, all right? C, percentage C for character, percentage S for string, percentage I for integers, okay? Integers, same as percentage D, same as percentage D. And of course, there are those others if you want to try them out. So, want to play with us, see what happens. All right, so now let's try doing the same thing using a do. I want you to go try now. This is your experiment. I've shown you how to use a while loop. I want you to go try out a do while loop. A do while loop. The structure, you'll find it. You can even Google do while loop in C. Okay, you'll be given the structure here. The structure is given in many places. You can see here, do while loop. That's the format. Do, the first you do, where you do whatever you want to do. You immediately you do that, you increase, then you do the while. For maybe I'll just give you a very quick example. We are using a do while loop. So for the do while loop, you repeat the same logic. If you follow what is here, you do like the while, but then the while is outside. So let's do that. If I is 0, now this part is going to be do. The next part will be do. In the do, that's where we are printing the number. And after we print the number, we increase. Then after that, we apply the while. So we are saying do, we start with I being 0. I is 0. Then we do display the value of I, in this case 0. We increase it by 1. Then we test it whether it is less than or equal to 10. If it is true, we go back to the do. We do the code inside here. We test, we go back. That is the logic for a do while loop. So, sorry, I think this one is not here after the while. This is just a semicolon here, I suspect. What is it saying? There are so many of these. You see that? Same effect. Same effect with a do while. So you can try that out. These things you need to go and try out, but otherwise learning them like that without trying out will be difficult. So I'll show you a for loop. A for loop. Now the for loop is my favorite one, so it's a for loop. Now the for loop has a different structure. The for loop has a different structure. The for loop will be taking the structure like this. For as a keyword. You learn start with for. The first part is what we are calling initialization, if you remember, followed by condition, followed by continuation, loop continuation. Okay. So initialization is where we are saying, where are we starting? In our case, we are starting at 0. So we say int I is 0. What is the condition? Whatever must be true for us to repeat. So we say I less than or equal to 10. What is continuation? The I++. Okay. Then inside here, the for loop, you do your code. That's where you write your code. And what is the code? Print F. We want to format the values. And the number we are formatting here is the I itself. That's what we want to display. And we want to ensure that it is always displayed on a new line. Okay. Run that. Saying there's an error for int. For what? What am I doing here? For the semicolon at the end. All right. Yes, that one. So it's giving you the same result. Initialization here. That means we are starting I at 0. Then I must be less than or equal to 10. If it is true, then we print this message. Then we go back and increase I by 1. We go back and test it. If it is true, we print the number. Then we increase I by 1. The new number is less than or equal to 10. Displays it, increase it by 1, test it, display, increase, test, display, etc. I can do the reverse. I can now do starting from 10. Now this one will be the reverse. So we are starting with the 10 and ending at 0. So our initialization will be I is 10, starting with 10. Now the condition will be as long as the number is greater than or equal to 0. Now we are working in reverse. Now instead of increasing the number by 1, now we'll be decreasing it by 1. So I minus minus. I minus minus means keep decreasing by 1, and you keep displaying your value there. So you see now we have the effect of 10 all the way to 0, downwards. In case you don't want it to be 1, 2, 3, 4, 10, whatever it is, you can display it in. So now let's do the opposite, what we did before. Less than or equal to 10. I'll show you something else. So this one has the effect of showing you 0 to 10. Let me even start from 1. So 1 to 10. What if I want to do 10 to 100? What if I want 10 to 100? What would I do? If it's 10 to 100, we will not be using plus plus. We'll be using something different. So instead of saying I plus plus, I will say I equal to I plus 10. I equal to I plus 10. So keep adding 10 each time. Like that. Okay. Then now, because I want to display up to 100, so my maximum will be 100. So you see now we have 0, 10, 20, all the way to 100. If you wanted to skip 5, 5, you can do that. Just ensure that you are able to do 0, 5, 10, 15 in that order, all the way to 100. I don't know whether I'm understood. Type OK if that is so, or confirm with your thumbs up. If something is wrong, you need some explanation, tell me. Right, a lot of thumbs up, meaning you people are following, which is good. That's good. Now the final test with we are going to construct. If we complete that, we are done with the task for today. We are going to use loops to display a number on the left and the square of that number on the right. Let's do that. Someone has raised a hand. I don't know who. Let me check. Gitari Frederick, you have your hand up. Or in our way, your hand is up. What is it? Unmute and speak. Otherwise, lower your hand, please, so that you can continue. Gitari, if you have something, you can ask. I will assume you have raised your hand by mistake, so let's continue. So now here, I want us to do, let me call it a table of numbers and their squares. That is a comment. So what I want to do is to display the numbers 0 to 10. All right. Starting from 0, stopping at 10. And we are doing plus plus. I plus plus, remember, I plus plus can also be written as I equal to I plus 1 as an alternative. Please know that. I equal to I plus 1 is the same thing as I plus plus. Be aware. So for now, let's work with that. We get 0 to 10, which is okay. And maybe I should work with starting from 1. I want the numbers only. Yes. 1 to 10. Perfect. Now, what I want is to display those numbers together with their squares. So let me first, before I enter the loop, before I go inside the loop, I want to display the heading. Print F. The heading will be number with a tab square. That's what I want. A number tab square. Let's first see whether that's going to be displayed. I'll print F. There's a mistake somewhere. Semicolon missing. All right. Semicolon missing. All right, number square. Let me underline it as a heading. Print F. Now I'm going to underline it like that. I'm also going to underline this one like that. Let's see that. Underlining is okay. Now with that underlining, now we have the headings. Now I want to display each of these numbers, but after the number, I want the square. So where was I displaying the number here? In the loop. So we were displaying print F, we format the number on a new line, and we display the number. Now I don't just need the number, I also need the square. So format %D tab %D, because we also need to, we now need two things. We need the number here, a tab, the square of that number. So you need to display two things, the number and the square, separated by a tab. Okay? So the number will be I, the square of I will be I times I. You know that. The number, a number squared by a number multiplied by itself is the same as the square of that number. All right? So we do that. Now it's giving us the result we want, but the formatting is not very good. I want one to go to the right. So that means I may need to add another tab. Two tabs. Let's see. Two tabs. No, I've interfered with the tab, the wrong tab. The tab I want is on the results. All right, another tab. Yes. That's what I wanted. So you have been able to create your program that can give you the number and the square, the number and the square, the number and the square, using the idea of loops. Well understood? Okay. Jason, you have your hand up. Yes, ask. Fred, your hand is still up. Gitani, Fred, your hand is still up. All right. So I'm getting a lot of confirmation that you're understanding this. So let me share the code with you so that you can go try it out on your own, run it and learn from it. There you go. I've shared the code. You can try it out on your own. Is there something else you want me to explain? I think that summarizes the idea of loops as well as decision making. The last topic we have done. Ronald Oweno, your mic is misbehaving. Ronald Oweno, your mic is misbehaving. If I see your mic is misbehaving, I'm going to kick you out of the meeting. Yes, I'll get you out of the meeting room. I believe we have covered the two topics. We have been able to demonstrate the ideas. And maybe there are those who are not able to understand. Let's do a very simple one, which is to test whether a number is odd or even using if statement. So let's do that very quickly. We end our class. So in our case here, testing for odd or even. Testing whether a number is odd or even. Okay. So what we need to do is we create a variable int number. Okay. We ask the user to enter the number. So printf. In printf, sorry, we are asking the user to enter the number. So enter a number, okay. The user is going to type a number. We need to capture the number using scanf. In scanf, we format the number as an integer, %d. We will assume the user is going to type an integer. Then we capture the integer using ampersand. The variable is number. Remember, the variable is here, number. Okay. So with the value captured from the keyboard now, we can go down here and test if the number %2 equals 0. I'm saying if number %2, meaning when you divide the number, the value number by 2, what remains? If whatever remains is equal to 2, then we go inside this if, and we display the message printf %d, the number itself is, then we give a message, okay? This number is odd, is even. Okay. Else printf, the number itself that you typed is odd. Let's make it better. So %d is new, but what's that number? The number itself is number, and here the number itself is still number. And then of course we return 0. Let me see, maybe I've done that very fast, maybe there's a mistake also. Enter a number 5. 5 is odd. Enter a number 4. 4 is even. Enter a number 66. 66 is even. Enter a number 43. 43 is odd. Enter a number 100. 100 is even. Enter a number 90. 90 is even. Enter a number 0. 0 is even. Yes, because 0 divided by 2, the remainder is 0. So it's 0 will be treated even like that, even though it doesn't make sense. So you have to create a filter for that. I believe this one should be straightforward, should be clearly understood, and I would like us to end our class. So unless you have a question, this marks the end of our class. If you have a question, unmute yourself and ask. Otherwise, in 1 minute,